Directivity of antenna or gain of an antenna. We will also get into say how we can derive the relationship between gain and directivity of an antenna. Now we will try to define the gain of an antenna. What is gain of an antenna? Gain of an antenna means it is a ratio of maximum radiation intensity of a test antenna to the maximum radiation intensity of a reference antenna, provided both antennas are given with same input power. Here test antenna means we are provided with the antenna and we don't know the gain of that particular antenna. Reference antenna means any antenna whose gain is known or a familiar antenna, something like dipole antenna, horn antenna, lossless isotropic source, or any antenna whose gain is known or calculated. Gain, it is a ratio of radiation intensity. So radiation intensity means it is power radiated per unit solid angle. So gain can also be defined in terms of radiation intensity or power. Like it is a ratio of maximum power from a given antenna to the maximum power from a reference antenna. Suppose if you are provided with two antennas and one antenna has got a higher gain than the other one, what does it mean actually? An antenna with high gain is able to focus the transmission of signal energy onto a particular direction. So as the gain of the antenna increases, the radiation pattern of the antenna will look more narrower or the beamwidth will be very less. Gain of the antenna is related to the input power as gain is equal to 4 pi times radiation intensity divided by the total input power, or we can in short write it as 4 pi u divided by Pin, where u represents the radiation intensity of the antenna. Directivity or directive gain of an antenna. Directivity is the ratio of radiation intensity in a given direction from the antenna to the radiation intensity averaged over all directions. Or we can even compute the maximum directivity as maximum radiation intensity to the average radiation intensity. Radiation intensity means the power radiated per unit solid angle. We can even relate directivity with respect to power density as maximum power density to the average power density. How can we compute average radiation intensity? It is the ratio of total power radiated by the antenna divided by 4 pi, because radiation intensity is power radiated divided by solid angle. Inside a sphere we have total 4 pi steradians. That is why we are dividing it by 4 pi in order to get average radiation intensity. Directivity, it is a dimensional quantity and it indicates the effectiveness of concentrating power into a limited solid angle. So as the directivity increases, the solid angle will get reduced. Maximum directivity is the ratio of maximum radiation intensity to the average radiation intensity. So we can write it as maximum radiation intensity represented by U max. Then average radiation intensity is represented by U0. So this is equal to U max divided by power radiated by 4 pi. So that is known to as average radiation intensity is power radiated by 4 pi. That we will get it as 4 pi times U max by P rad. Now, let's get back to the equation of gain. We already understood gain is equal to 4 pi times U by P in, where P in represents the total radiated power. Now, if you remember the relationship between input power and the power radiated, it is related as input power is equal to radiated power divided by eta. Eta means radiation efficiency, or we can even say the total power radiated is equal to eta times input power. The value of eta can vary from 0 up to 1. It represents the efficiency, so that means it can take a maximum value up to 1 or 100%. So substituting for P in, we get it as gain is equal to eta times 4 pi u by P rad. So now you just compare the equation of this gain and the equation of this directivity. What you can get is, you will understand gain is equal to eta times d. That is, if you know the value of gain and directivity, they are related. That is, gain and directivity, they are directly proportional. If the value of directivity is high, that means that value of gain is also high. The value of directivity can vary from 1 up to infinity. For an ideal isotropic antenna that radiates signal in all directions, its directivity D is equal to 1. Now let's look on to the few takeaway points from this particular video. Gain is the ratio of maximum radiation intensity of a test antenna to the maximum radiation intensity of reference antenna, provided both antennas are given with same input power, whereas directivity is maximum radiation intensity to the average radiation intensity. Gain and directivity is directly proportional. That means if the value of directivity is high, that means gain is also high. Gain is a sort of practical quantity that will take into account all the losses, whereas directivity, it is a quantity more like an ideal one. It doesn't look into the losses that happens in the antenna transmission. Directivity is also related to the solid angle of the antenna, as D is equal to 4 pi by omega A, where omega A represents this beam area or beam solid angle. That means if directivity is high, then solid angle is narrow. Let's see what happens to the radiation pattern of the antenna as the directivity increases. The first figure, this is for a dipole antenna, and the directivity value is 2 dB. I. This I represents the directivity is measured with respect to an isotropic antenna. So here it's more like a sphere, that means its directivity is less. But when directivity is 8 dB, the radiation pattern is more narrower. Here look at another radiation pattern. This is for 10 dB high, and here the radiation pattern is more narrower than a 8 dB one. And when the directivity becomes 14 dBi, the radiation pattern is becoming more narrower. That means as the directivity increases, the antenna is able to focus its energy onto a narrow solid angle. So that is what I said in the last point, that D is equal to 4 pi by omega A. That is, as directivity increases, the beam solid angle will decrease.